So if we're going to run 23C, then we're going to set our image name. I like to script things that makes it a little bit more portable. Maybe that works for other people, maybe it doesn't. But if you want the 23C database, we're going to use this image name. If you're going to use the 19C on Windows or the Intel Mac or Linux, you're going to use this image, and you're going to have to do the Docker login in order to pull that. And then the same thing for the ARM. This is the image that we're going to use for 19C on the M1 Macs. And then we're going to pull that image. That's it, Docker pull, and then the image name. And then once it's done pulling, which takes a couple of minutes because it is a good-sized image, then we can go in. So I can do Docker images, and this will list all of the images. And you can see on this system, I've got a whole bunch of images that I've pulled onto this machine. But you will see right down here, this container registry .oracle.com/database free latest. That's a 23C free database image right there. So that's all right there and available once we've pulled it. So we pull that image, and then we can do that Docker images to list, and we can see all of the different images that we have. And then at that point, we could do this. We could run this command, and this will give us a quick and dirty database. We just do this Docker run -d. I'll explain the different parts of this in just a minute. We could run this. This is all you need to do in order to create a database on your system. And this Docker logs command that you see here is just going to show us the output from the container. At first, you'll see the database configuration assistant because it creates a database the first time we start it. But we actually don't want to do this. This is bad. This is a quick and dirty database, and it will certainly do everything you want it to do. And it's a real Oracle database. It's not like a toy. It's not like a half database or anything like that. It's absolutely 100% identical to anything that you would run on a VM, on bare metal in the Oracle Cloud or wherever. But this isn't really useful for us. So I'm going to show you something that's a little bit more powerful and useful. So we're going to do a few things to kind of prepare our environment first. And I apologize because there's a different set of commands that you're going to run if you're on a Mac than if you're on a Windows system or a Linux system. And it just has to do with how ownership of the file system works. So if you're on Windows or Linux, we want to add a group for oinstall so that we can actually get to the files that Oracle is going to create, because inside the container, it runs as the Oracle and oinstall group. It creates those for us. So we're going to add the oinstall group. We're going to add the Oracle group. And then we're going to add the oinstall group to the current user so that you don't have to sudo for everything. Kind of a pain in the neck sometimes. You don't need to do any of that if you're on a Mac, though. The next thing you want to do is we want to go in and we're going to set a base directory where we're going to put all of our database files. And this is so that we can persist those files on the local system, which is really important. You'll see how this works in a little bit. Here on a Linux system, I'm just putting it under this /or-data directory because it's just convenient. You can make it anything that you want. So we're going to create that directory. We're going to make it owned by the Oracle and oinstall user. Otherwise, our container, which is running as the Oracle and oinstall user, isn't going to be able to write files. Can't create a database. Not very helpful. And we're going to do a chmod on that. On the other hand, if you're running a Mac, you can't create a directory in your root because it's a read-only file system. So you have to create something under your user home, which is why I've got the little squiggly /or-data there. And then all we have to do is just create that directory. So we've created this directory. This is our root directory where all of our database files are going to exist. Next thing that we're going to do is we're going to do one extra little thing that lets us have like an NFS directory that we can share among a bunch of different databases if we wanted. We're going to call it scripts. So you can just drop scripts in there, and your local machine, you can access that scripts directory and you can create things in there. From the container, you can access that scripts directory and create and read and edit files in there. So it's like a shared NFS directory. So create that directory. And then we're going to just set some variables. I'm going to call my container ORCL because I can, I suppose. And if you're running a 19C database, we're going to create the Oracle SID as ORCL and the pluggable database name as ORCL PDB. You can make it whatever you want within the limits of what you can actually do with an Oracle database. But these aren't required for 23C because it's going to set that automatically for you. And then this is the scary part. We're going to create some directories under that Aura data directory, that base directory that we set up before. And the reason we're doing this is so that we have a dedicated place we're going to put our diagnostic files, our data files, and our audit files. Now, the reason this is important is these are going to be saved locally on the machine in a directory that we can get to very easily. And these files and these directories will persist even if I were to delete the container, which you'll see later is a really cool, important thing, not only because you don't want to lose your data, but because we can manipulate that and do all kinds of neat things with it. So what we're going to do here is this is just a for loop. It's going to go through. It's going to create some directories. It's going to clean up the directory if there's anything already existing there. And then you see these Docker volume RM and Docker volume create. These are creating what are called bind mounts, just so that Docker is aware that they exist. You'll see where this comes into play a little bit later. If you're on a Mac, you don't need all the sudo stuff. And then with all of this set up, we're going to actually run a container. So remember, we could do this quick and dirty database creation back here. And let's look at what this command is. First is the Docker run. Docker run says, I want to take an image and I want to run it. This -D says, I want to run it in detached mode. So it's like running it in no-hup. So it runs in the background. If I didn't run it in detached mode in the background, then I would issue the Docker run command, and it would just like take me into the container. And when I exited the container, my database would stop because it's tied to my local session. So we don't want that. So we run it in detached mode, and then it runs in the background. I can log off my system, log on my system, and it'll keep going in the background. I'm going to give my container a name, MyDB in this case, just because it makes it easier. If you don't give your container a name, Docker will assign a name for you, and it's usually something like it's 2 words, and so it'll be like incredible populace or hackney goats or something like that. And it's always bizarre and sometimes entertaining. But that's how you would then be able to reference the container in a friendly fashion. So I'd rather have a friendly name that I can get to. And then I'm going to use that image name. This is how I'm going to reference it. And this Docker logs command, you'll see in just a second, this is going to show me what's going on inside my database. So that was the quick and dirty command. Here's the actual useful command. And I know this looks a lot bigger and scarier, but it's really kind of the same thing. We're running this Docker run -D, so it's running detached. I'm giving my container a name, and then I'm going to specify a directory for my data and for my diagnostics and for my audit. And you'll see these are all set to volumes. So I'm saying to Docker, when you start this container, there's a directory in the container called /opt/oracle/admin, and I want you to map it to this volume that we created, which maps back to an actual physical directory on our system. If you don't do this, then all of these files get created inside the Docker virtual machine itself, and they sort of disappear on you, and they're difficult to manage. And if you remove the container, the volumes go away too, which would be bad for data. We're mapping this volume for the scripts as well. If we're running not a 23C database, then we can set the SID and the pluggable database name. And then we've got this important thing here, which is the port mapping. So port 1521 in the container is our listener, our database listener. And in this case, I'm saying that database listener 1521, I want to map it to port 1521 on my local host. And it's the first number that you see there. is the local host. The second one is the port in the container. And this is going to allow me to connect to my database later using something like SQL Plus or SQL Developer. And the last little bit is I'm telling it the image name. And then I've got my my Docker logs command so I can see the output. This is the command for running 23C. The only thing that's different here is that I don't have the Oracle SID and Oracle pluggable database name because they're set in the container itself. There are some other things that I can set in my Docker run command just with these -e, which is a way of setting an exported variable in my system. So I can set the Oracle password, the SID, the pluggable database name. I can set the character set. I can set the time zone. There are a whole host of other values that I can define. And you'll see if you go into the container registry or if you go into Oracle's Docker build scripts, you can see all of the different values that are available. But these are the main ones that we would be using on a regular basis. So this is how you customize a database. And then once you've run it, then we can log into it with this command called docker exec. And we're just basically saying, I want to execute a command. I want to execute it in interactive TTY mode on a particular container. And then this is the command that I want to issue. And we can take a look over here and you can see what this looks like. So this is running on my local MacBook Pro. So I run this docker exec command and I get this bash prompt. And now all of a sudden, well, this does not look like a Mac, not at all. In fact, if I what is it, Etsy, Red Hat release, it thinks it's running Enterprise Linux 8.8. Definitely not a Mac, but this is running on my Mac. And my environment is set. So I can go in here and I can run SQL Plus. I can run RMAN. Everything is here. This is, I want to really emphasize, this is not a pretend database. It is an actual 100% real Enterprise Edition database. It is not toned down or trimmed down in any way. Identical to what you would run in an enterprise environment. So that's how we log in. And then connecting from SQL Developer, really similar. I go in and I give my connection name. I've got my username and my password, and my host is going to be localhost, and my port is going to be the port number that I assigned when I created the container. And I've got my service name, and I can test that, and I can connect, and same thing. Oops, here we go. And so here's my database. All right there. And it's all portable. It's running on a laptop. The reason I'm not showing you stuff on the Windows machine is my Windows environment, I don't normally use Windows, is this Dell laptop that I got on Amazon for like $200. And it's very, very slow. So not the best example of how incredible things are. So very simple and very straightforward for us to go in and make connections, and we can do all sorts of different cool things in our local environment without having to connect. You can take this on a plane. I don't need a network connection or anything. My entire infrastructure is running on my laptop. All right, I told you before I was going to show you how fast containers are. So let's take a look here. This is running on MacBook Pro. This is an M1 chip. And you can see here, this is my Docker logs output. And in fact, I'll show you, I did a Docker run, the exact Docker run command you saw earlier. And this is what you see when it first starts up. It's going to go out and it's going to start my listener. And then it's going to create a database because I don't have a database already on my system. And on this machine, 1415 UTC 1408. So this took about 7 minutes to create a database on an M1 with 16 mega memory. Not bad. Creates my pluggable database and so forth. And then it starts tailing the alert log. So this Docker logs at any point is going to show you the alert log on the database. So let me switch over to this other screen. And what I'm doing here is I'm stopping this container and I'm going to immediately start it. And you'll see over on the right-hand side, my alert log is going to show the process of the database shutting down and starting back up. So there it is. It's stopping. The entire container is going to stop. This is the equivalent, if there is one, of starting and stopping and a VM. My logs exited when my container exited. And here we are. Database opened. That's as long as it takes to restart a database. Really, really fast. You couldn't do that fast with a virtual machine because a virtual machine has to start the operating system. In a container, it's sharing the operating system with the local host. So there's no need to stop and start an operating system to reboot things. So very, very fast. All right, let's take a look at that data volume because we kind of went through that a little quickly at the very beginning, and I want to share with you and impress on you how important it is, how valuable it is to have that data stored on my local system. So I'm going to show you here. So this is my data directory. This is where I'm storing my data. And I'm going to change into this Oracle subdirectory because that's where my database is. And you'll see I've got my audit, my database, and my diagnostic files. And if I go into data, oh, now I've got a subdirectory for my database. I also have this other subdirectory for dbconfig. Let's look at that in just a second. But under my Oracle directory, here's all my database files, redo logs, control files, the pluggable database files, and so forth. But what I want to show you is that dbconfig directory. So in that dbconfig directory, I've got a subdirectory for my database, and I've got a listener file and a TNS names file, or a tab, SP file, password file, everything that I need for the configuration of my database. And if you think about it, if you've ever tried to move a database from one machine to another, well, normally you would install software and then you would move the data files or do an RMAN backup and recovery. And then you'd have to worry about, oh, my listener and my TNS names file and all this other stuff. I need to move all of that configuration over also. Well, here on my container, it's all built into this single parent directory. This is everything that I need for my database. In fact, if I navigate back just to the root of this data directory, okay, so my Oracle/data, yeah, it's not on this machine. This is going to have everything that I need for my database, all of my configuration and all of my data. And what makes that important is that, first off, if I were to delete my container, or if my container wouldn't start for some reason, I can still get to my diagnostic information and I can maybe see what's wrong with the database if I need to. But all of those database files are going to be in that data directory, which means that everything for my database is saved here. I don't need to go and get anything else. So if I wanted to create a database instantly and not have to go through the process of running the container and having it start and create a brand new database, well, all I've got to do is copy all of those old gold files from the original database into a brand new directory. I go through the whole process of creating the same directories like I did before, just under a new container name, call it clone in this case. And then I'm going to copy what was in the original database's data directory over into the new clone directory. And then I run almost exactly the same run command that I did before. The only thing I'm going to change is I need to change the container name, because I can't have two containers with the same name running in the same environment. I want to make sure that my data, I've changed the container name in this case because I'm looking at the clone. I need to keep the same Oracle SID and the same Oracle PDB because these are database files associated with a particular Oracle SID, right? And I also need to change the port because I can't have two environments or two systems that are running on the same port. And then I'm also going to use the same image name, although you don't have to, because I could start a database under, let's say, 19.15 using a 19.15 image. And then I stop that database and I restart it with the same command using a 19.19 database image. And what have I done? I just upgraded my database just by changing the image name. All I need to do then is start the environment and run my data patch command, and it runs the patching scripts because it looks at those data files at the headers and so forth and says, oh, these were from a 19.15 database. My inventory is from a 19.15. I'm now running 19.19. I'm going to apply the differential between the two, and we've successfully patched a database because you don't actually patch in a container. You patch outside the container by using these images. It's much, much faster that way. It's like the new out-of-place patching that Oracle's been pushing. Instead of upgrading and making all sorts of changes to an existing directory, then I'm just giving a brand new clean installation at the new version, and I get everything that I need. So that's how you would upgrade a database. But what I'm showing you here is now I have this gold data set, and I can reproduce this gold data set, and I can start new databases in the same amount of time that it took for me to do this stop start command that you saw here before, because all the data is still there. When the container starts up, it looks in that dbconfig directory and it says, do I already have a database? Oh yeah, I do. I've got data files and I've got this lock file that it creates in the background. Yeah, I've got a complete database right there. So I'm just going to start it because I don't need to create one, because the SID is the same, the PDB name is the same, all of the control files and so forth match up. So very, very fast, very convenient. And that means that I can also make like intermittent snapshots of my data if I wanted to. An example of how powerful this was, a couple of years ago, I was working with the Oracle auto upgrade team, and we had an issue in auto upgrade that I was trying to demonstrate for the folks. And it happened like halfway through the upgrade. So you'd run a bunch of stuff and then the upgrade would run and it would go for like 20, 30 minutes and it would fail. So I'm on the screen share and I'm showing them all of this. And they said, oh, okay, yeah. So here's what we need you to do. Make this change and this change, and then restore your database back to the original point and run it again. And we'll schedule another call for tomorrow. And I said, no, that'll take like 30 seconds because I've got a snapshot of the database that I took right at the point before it failed. All I've got to do is restore that snapshot. I have the database exactly like it was at that point in time. I don't have to use RMAN or anything like that. I'm just a simple copy command. And then I rerun it with the changes that they asked for. And they were just stunned, just like, show us this again, show us this again. So we spent like 30 minutes going through and demonstrating. But this is the power that you have with this technology. When you start talking and working with developers, you can create data sets for them that are just these assets. You don't need to do export, import. You don't need to do RMAN. You don't need a DBA to empower your developers or your development team or your QA team or your testing team to do any of these things, because we have this data that's available. So let me show you how quickly this is running on a Linux machine. I'm going to start a 23C database. And hopefully my session didn't time out. This is connecting to Oracle Cloud. All right, well, that's not running. Let me show you. Here's what we wanted to do. So all of these images that you've seen that I'm using are all built from a set of scripts that come from Oracle's Docker repository. And so this is a public repo that you can reach here at github.com/oracle/Docker images. And if you navigate down Oracle database, single instance, Docker files, you're going to see all these different versions that are available to you. And you'll see these same files that I have here available locally on this system. But I want you to notice that the file that we're using to install the database is the exact same file that you download from Oracle's software download page. And if you go in here and we do this create DB script, you'll see, oh, no, I'm sorry, that's the, here, I want the other one. Install DB binaries. So if I do / look for run installer, this is the exact same run installer command that you're running when you create a database in any other environment. It's just that the beauty of this is that you don't have to do any of this stuff manually. And here is a 23C database. Look at how fast that ran. I realized that I jumped over into another session, but this created a brand new 23C Oracle database in the time it took me to take you over to this other screen and look at a couple of different files. That's pretty impressive. You got to admit, that is pretty cool stuff. And like I said, absolute real 100% genuine database. Nothing different about it. My logs command. With the images, the method that I showed you where we're pulling those images, that is we're going out and we're getting this pre-built image, but you can go into this repo and you have all of these scripts available to you, including things like the DBCA response template file. There's a response template for the database installation as well. And you can go in and you can make changes to those scripts and modify these image files to be pretty much any configuration that you want. And once you run the build command to create your own image, now you have this custom image. And this is all just shell script. So if you're familiar with shell scripting, you should be fairly familiar and able to go in here and do all of these different things. And I want to show you one last thing, actually two last things. So I do a lot of work with Docker and databases and so forth, and I have a repo as well. And mine has a whole bunch of different flexibility built into it because I'm constantly building different versions and so forth. I take a little bit of a different approach. So if you're interested in taking a look and seeing some slightly different builds so that you don't have to go in and edit things, you're more than welcome to take a look at this script repo. And I'll give you one last look through our Docker desktop here. So you can see this is my Oracle database running on my local machine here. And if I click on this, this is my log output like you saw from the command line. I can click on this inspect and I'll see all sorts of different values from within the environment, including where I've mapped data. This is my port mapping here. And you'll also be able to go through here and you can see things like all of these variables that are set in the environment. So you've got a lot of visibility into what's going on inside the container. And in fact, from here, I can just run this exec command. And this is a shell inside my container. And so I can run the same commands better formatted now. So I've got that available. I can also look and I can see everything that is in my environment. And this is another really important aspect of what makes containers so valuable and why we're going to be running databases in containers. If you're not already, you will be soon, because this gives me an exact catalog, what's called an SBOM or software bill of materials. I can see everything in my file system that has been changed, and I can scan this image and look for vulnerabilities. Can you say that about the database that you go in and you work on manually, and maybe somebody else goes in and they add something to a directory, or they run some yum command or whatever? You've got all these hands on your database servers, and there's no real way for you to reproduce or guarantee that someone hasn't done something nefarious, especially in a larger environment, if you don't have version control and configuration management built around it. So right here, I can see that files in my home directory were changed or modified, and I can go in. Oh, look, bash history was added. So I've got this inventory and I can see everything that's taking place here. The other value of images is if I have an image of my database that's running in my primary data center and my primary data center explodes and I've got to copy all my data, how do I reproduce my database somewhere else? If it was like 15 or 20 different iterations of people going in and changing and doing all sorts of different things with an image, I just put it in the target environment. I start the database under that target environment and restore my data. Very, very reliable, very consistent way of building things. And then I've got stats here too, if you like graphs.